All right, examples 1, 2, and 3 all involve finding the greatest common factor of an algebraic expression. And to find the greatest common factor, we're going to factor each term. And if you remember, terms are separated by pluses and minuses. So if we're looking at an algebraic expression, a bunch of stuff involving a bunch of letters, plus or minus a bunch of other stuff involving a bunch of numbers and letters. So they're going to be separated by pluses and minuses. Each term factored into its prime power factorization. That means we go to prime numbers, and then we do, like, if there's 2 2s, it's 2 squared. If there's 3 3s, it's 3 cubed. All right, so write them in power form. List each factor that occurs in every factored form. So if a 2 happens in the first one, and the second one, and the third one, it counts. If the 2 happens in the first one, second one, but not the third one, 2 doesn't count. So it has to happen in all of them. If there's only 2 terms, a 2 happens in the first and second, fine. A 3 happens in the first, but not the second, it doesn't count. So only factors that occur in both. Don't worry about the powers, worry about the bases. If it happens in every one, write it down. For every common factor, write the smallest power. And this is the thing that messes people up. We're trying to find the greatest common factor, but we're taking the smallest power. The smallest power is what's going to be common. Once you take the smallest power out, that object no longer exists in that term, so it's no longer common. So you take the smallest power of each common factor, and then whatever you get listed in your thing to its powers, multiply it all back out to get the greatest common factor. Okay, today we're going to be finding the greatest common factor. Every problem is going to say find the greatest common factor. In the next couple lessons, we're going to be factoring the greatest common factor. That's slightly different. There's a little extra to that. I want to make sure that there's a distinction between the requests. So when it says find, we're going to do what we're doing today. In a few lessons, when it says factor, that's going to be a different direction. This is going to be a step in that direction, but then we're going to have to do extra stuff afterwards. So example 1, find the greatest common factor of 8z to the 4th m squared p minus 12z cubed m to the 4th p squared. The 2 terms, the one underlined in blue, the one underlined in red, are separated by a minus sign, making them separate terms. And if we're looking at a prime power factorization, all I really have to do is factor the number. So we look at 8, that's 4 times 2, and then 4 is 2 times 2. Bring the 2 back down. 8 is the same as 2 to the 3rd power, so this problem here, or this term here, is 2 cubed z to the 4th, m to the 2nd, p to the 1st. And I do recommend writing down a power on everything, so if there's an out of power listed, put a first power on it, just to remind you that there are going to be powers there. Then the minus sign occurs. The minus sign is irrelevant in the finding of a greatest common factor. Okay, all it's doing is separating the 2 terms. Look at the number 12. 12 breaks down to 4 times 3, or 2 times 6, take your pick. And then 4 is the same as 2 times 2. 3 is still just a prime number 3. 2 times 2 times 3, better known as 2 squared, times 3. And then we have z cubed, m to the 4th, p squared. And this 3 is to the 1st power. So again, getting everything written with a power on it, that's job 1. Break apart the numbers into its prime power factorization. The letters are already factored. There's no way to break down z into something times something. Z is z, it's raised to a power. So the letters are already factored for us, the numbers aren't. That's what we have to do first. Step 2, we're trying to find common factors. Factors are the bases. So the bases are 2zmp, 2, 3zmp. Those are the factors. Those are what I mean by find all the common factors. So 2 happens in this one, 2 happens in this one. I don't care about powers at this point. I care about what's common. I'm going to write GCF equals, and then anything I'm underlining I'm going to put down here, so 2. Okay, don't worry about powers yet, just worry about what's common. Next thing I notice to be common, this has a z, this has a z, so z is common. I notice that this has an m and this has an m, so m is common. And I notice this has a p and this has a p, so p is common. Every one of those objects, 2z, m, and p happens in both factored forms. 3 happens here but not there, so 3 is not common. So again, common factors in both, making it common. Then, step 3 asks us to find the smallest power for each thing. So here's my 2's. My choices are 2 and 3. I'm going to take the 2. Here's my z's. My choices are 4 and 3. I'm going to take the 3. M, 2 and 4. I'll take the 2. P and P, 1 and 2. I take the 1. So in each case, between the 2's, 2 is the smaller power between the z's, 3 is the smaller power between the m's, 2 is the smaller power between the p's, 1 is the smaller power. Okay? Once we've established the smallest power of each one, that is the greatest common factor. That's the largest thing that evenly divides both of those objects. So to finish this problem out, I simply multiply all that stuff out to the best of my ability. Numerically, 2 squared is equal to 4. Everything else is just letters to powers, so z cubed m squared p. For a final answer, I usually leave first powers off. In my work, I like to put the first powers on. Directions said find the greatest common factor. That is the greatest common factor. Again, in a few lessons, they're going to say factor the greatest common factor. That's going to be step 1 of the factoring problem. Step 2, we got to do some extra stuff.